Can you hear me? Hello. Hello, can you hear me? Hi. Hello. Hello, hello. Hi, Crystal. Hi, Eddie. You remember me from 2 weeks ago? Hi. Hi. Why you are so hardworking. Never go for holidays? Yes, that's good. Hey, hello, Pia. Hey, hello. I see so many familiar like names. Hello. Hi. We'll start in about 1 minute, okay? There's a countdown over there. You're doing primary six science today, but because your school haven't started for P6, so we're actually going through like your previous year's topics. Okay? Hi Crystal, you're P5 this year, that means next year P6? Oh, today don't have. Today don't have. Every week there will only be one Kahoot. This week is not for science. Yeah. Of course, you want to go through more questions with your. So we take turns, like different weeks, different subjects, different levels. We have Kahoot. Hello. I I cannot remember. Oh, I'm from the North Point outlet, the Yishun outlet. Yeah, yeah. Hello. Okay, I'm gonna start. Okay, the countdown is up. So, okay, okay, just a gentle, just let you all know. Hi, Hannah. Hey, Hannah, you really your P6 this year already graduate already. Still watching? I'm not teaching secondary one science. No secondary one science for A grader. Oh, so hardworking, Hannah. Okay, yeah. So, we are gonna have webinars. We have already started our online classes, so you can it's on top. Okay, so you can actually register for a free trial for all the different subjects like English, math, science, and creative writing. Okay, so let me start with the lesson. Sort of lesson, okay? Sorry, worksheet. All right. Hi, Anna. Okay, so we're still because y'all haven't started the classes in school yet, so I'm very sure y'all don't know. Not many of you know the concepts of the first few topics. So we actually be doing primary five related topics. Okay, and P3 and P4, but mainly P5. Yeah, correct. Okay, so let's go. Okay, those of you who don't have the worksheet, you can actually get the worksheet in our link, which is in our bio. The link is in our bio. Okay, which is the A grade at A grader LC. Okay, so let's look at the first one. If you all know the answer, okay, you can let me know. All right, but okay, let me show you. Okay, so for question one, we are doing electrical systems. Okay, today. So it says that Keith set up the following electrical circuits. Okay, so those of you who have your worksheet with you can just highlight and take down all your notes. Okay, all right. So every time you encounter a question and you see to find out, does anyone know what is to find out? What does it mean? Oh, you all know each other. Hi, Terence. Hi, Harmony. Yes, very good, Kiwi. Eddie, very good. It is the aim of the experiment. Okay, so always remember this important thing. Okay, it's the aim of the experiment. Okay, and your aim will always consist of a changed and measured variable. Do any one of you know which one is my changed variable by looking at the aim carefully? Thank you, Star. Or Stare. Stare or Star? Okay, Star. Thank you, YS. Which one is the change variable? Do you all know? Very good, Eddie. Yes, it is the materials. Okay, you see, your aim, okay, always remember for aim, right, is change variable, affects measured variable, okay, or yeah, as long as you see something that is different. Okay, sometimes in the aim, they do not have the word affects, right? So look out for something that's different in the experiment. And the thing that is different for this is the materials. So this is my change variable. CV means change variable, okay? And after that, we want to find out which one is the measured variable. Thank you, thank you. Yes, thank you. That is materials. Very good. Does anyone know what's my measured variable then? Anyone? Okay, so for measured variable, right, it's actually within the aim as well. Okay, so they usually will write the measured variable inside, which is whether the materials are conductors or insulators of electricity. So this is something that I want to measure, I want to record. Okay, that will be the results of my experiments. All right, so yes, it's something to do with the circuit, right? Whether there's electric current flowing through the circuit or not when I place the material there. Okay, so this is my measured variable. Okay, so over here, okay, every time you encounter such questions, okay, let me ask you, huh? Is considered okay. I personally I think that electrical system questions are actually the easiest to score marks as long as you are careful. Okay, that means you really look at each and every option carefully, okay, and all that. Okay, so for this, right, which one of the following correctly identifies, oh, today don't have, identifies the conductors and insulators of electricity? Okay, a lot of students, okay, straight away see, okay, no bulb lights up, means right, means that that particular material is definitely a insulator. Yeah, don't have. Okay, so for this, right, what must you do is that always identify, okay, where is my closed circuit? Okay, always. First thing you need to know, okay, first thing you need to find out is always conductors. Always find out the conductors first. Okay, why must I find out the conductors first? It's because if I find out insulator first, right, I find out which one the bulb doesn't light up, right? But if they're connected together and there are two materials there in the circuit, okay, may not both of them are insulator. Maybe only one of them is an insulator and it affected the entire circuit. So don't find out insulator first. Find out which one are conductors first. Okay, so do not make this. Yeah, sad. You all should know Kahoot. Okay, so make sure you all don't make like such careless mistakes. Okay, so find conductors first, which is closed circuit. Okay, so for this, based on my result, everybody must look here. Okay, if you all know the answer, you all can tell me. Okay, which one do you think are conductors? Which one do you think are insulators? Okay, so based on my results, right, you can see that the bulbs light up for A, okay, but not B. Okay, let's do one circuit at a time. Okay, so we can see that A and B is from the circuit on the left. You see, circuit on the left here has bulbs A and B. All right, so if A lights up, means that there is an open or closed circuit. Wow, you're also fast, huh? Yeah, the correct answer is 3. Very good. Okay, but is it if it lights up means it's an open or closed circuit? But I need to explain in case some of you got it wrong. Very good. Lights up means closed circuit, right? Okay, so I always use a pencil or a highlighter, but PSLE cannot use highlighters, use pencil and trace. Okay, so what happened is since the bulb in A lights up, means that there is a closed circuit here. Okay, so closed circuit means what? Which one are definitely conductors? Insulator we cannot confirm yet. Okay, but definitely conductors we can confirm. Very good, Y and X. Okay, so based on this, based on this, we know that W and X are conductors. Okay, so for here, we know that W and X are conductors. Okay, but take note, okay, everybody, do not straight away assume that, okay, Y and Z are insulators. It could only be one of them. Okay, maybe both, maybe one, we don't know. So we have to look at this one. Okay, all right, so let's look at the one on the right. The circuit on the right consists of bulbs C, D, E. Okay, so this is the circuit on the right. So based on that, based on the circuit on the right, we have closed circuits for C and E. Okay, so if I were to use a highlighter to indicate my closed circuit, very good, thank you. The rest of you, thank you. Okay, it would be C is this bulb over here. Okay, E is this bulb over here. Okay, so this tells me that my electrical current flow through here, goes down here, and goes down here. Okay, so this tells me a lot of things already. This tells me that my conductors, okay, we already know that W and X are conductors, right? So W is over here, X is over here, conductor. C means conductors, okay? And what else can I confirm that is a conductor now? Based on the circuit on the right. Any idea? What can I confirm that? Yes, very good, YS. Y is a conductor as well. So I can confirm that Z is an insulator. Now I can guarantee that Z is an insulator. So a lot of students just look at the left circuit. Okay, then you'll see, oh, okay, Z and Y, the bulb didn't light up, means both of them are insulators. So this is wrong. That's why I say electrical system is considered one of the easier topics as long as you are careful. Easier to score marks actually. So you don't just straight away just assume based on one setup. Okay, so based on this, okay, we will know that WXY are conductors, insulator is only Z. Answer is supposed to be number 3. Fantastic. Very good. Very good, Jessica. Yes, thank you, Eddie. Thank you, Hihi. And I read your name, Hihi. Sounds like I'm laughing. Okay, very good. Okay, so let's move on to the next one. Also, electrical circuit question. Okay, so let's look at this. You'll never go holiday. What lag for you? Is it laggy for you? Hmm? Okay. Okay, let's look at question 2, okay? If you all know the answer, then you all let me know, okay, through the chat. Okay, so over here, wow, you're so fast. I haven't even shown you the full question. Okay, Ravi wanted to find out. Okay, again, the moment you see the word to find out, this is my I always ask the same question. Yeah, I do. Yes, A, very good, YS. Okay, but this time around, what is my change variable? The answer is not 2 for this one. Must be very careful, okay? In this case, that's my change variable. Yeah, I teach in A grader, but I do teach online classes on Thursday for P6 level. Next year P6. Okay. And then but I don't teach P6 physical classes at North Point. But I do teach at North Point, but not P6, not for P6 next year. Okay, I see 4. Yeah, 4 is the answer. Okay, but so change variable is the arrangement of the bulbs. Very good. What about measured variable? Does anyone know what's my measured variable? Yes, very good. Someone mentioned arrangement of bulbs, but you get pushed up already. So I cannot remember your name. Okay, yes, brightness. Thank you, Kiwi. So the measured variable is brightness of the bulb. So everybody always remember, okay, you notice I keep repeating this again and again because this is very important. Aim, always make sure that they write down the change variable, and they usually state it as change variable affects measured variable. But sometimes the phrasing can change, so you must be very careful, okay? So when you see the word affects, always remember change variable affects measured variable. Yeah, 4, not 2, okay? The answer is 4. All right, so based on this, which 2 circuits should he use? So when it comes to such experimental question, always make sure the 2 circuits when you do, and you must make sure that it's a fair test. Fair test means that everything else is the same except for your change variable. So since my change variable is arrangement, look here, okay? Change variable is arrangement. My 2 setups can only have arrangement that is changed, not number of bulbs, not number of batteries. All right, so please be very, very careful. Okay, I'm gonna explain why not like 1, 2, or 3. Okay, so the correct answer is 4. Very good. Why not number 1? If you look at number 1, if you look at circuit A and B, does anyone know what's my change variable? For A and B, if I were to compare A and B, what's my change variable here? Number of batteries, very good. Look at the change variable for A and B. A and B, the thing that is different, change variable means something that's different, is actually the number of batteries. Okay? And actually circuit B cannot work at all because you see, positive and positive are linked to each other. It will not work. Okay? So A and B, firstly, B cannot work already. Okay? But the change variable, if we were to focus on change variable, it has the wrong change variable. Okay? All right. Yes, very good. Batteries. Okay, what about number 2? Does anyone know why number 2 cannot? What's my change variable for number 2? Or what's my change variable for number 2? Or is there more than one change variable for number 2? Number 2 is A and D. Good. Number 2, there's an extra but, right? Number of bulbs is already wrong. Okay. Yes, very good. All right. And the arrangement, this is series, then suddenly go on parallel. Yes, very good. Okay, so there is actually more. Firstly, wrong change variable. Secondly, okay, he has more than one change variable. Always remember, okay, in a fair test, you must only have one change variable. Very good. Yes. Okay, so number 3, does anyone know number 3 is wrong? Number 3 is C and B. Wow, this one also, C and B also headache. Does anyone know why C and B I cannot choose? Yes, firstly, number of batteries is changed. Secondly, yes, correct. There's again wrong change variable and more than one change variable. Okay, so your answer is supposed to be number 4, whereby you choose C and D. If you look carefully, everything else is the same except for the arrangement. Number of batteries is the same. One battery, two bulbs, just that the arrangement is different. C is in what? What arrangement is C in? Oh, very good, Luna. Voyager. C is in series, very good, hee. And then D is in parallel. Okay, so we have our change variable there. Very good. Thank you, Eddie. Thank you, YS. Thank you. Okay, so now let's move on to question 3. Anyone has any questions so far? Oh, so fast you answer. Thank you for your answer. Jessica, here, yes, very good. Okay, number 3, very straightforward. Okay, the one just need to remember, think logically, use your science concept. That's all. Okay, nothing much to explain. Okay, so for this, all right, the correct answer is 1. That's very good. Okay, it's because which of the following are ways to conserve electricity? Okay, conserving means what? Your English, that's your English. Oh, your name is Felice, is it? Hi, Felice. Because I see your IG, then your name, and then I call you accordingly. Yes, it's to save electricity. I don't want to use so much. That means I must use lesser electricity. So you have to choose the option that shows me that you will use lesser electricity. Okay, so in this case, switch to energy saving light bulbs. Because of the word energy saving, you will save electricity. So I'm going to choose A. Okay, you have to choose B also, because when you turn off electrical appliances when not in use, you are using lesser electricity. So you are reducing the usage. Very good. And for C, using the air conditioner, you are going to use a lot of electricity. Oh, yeah, it's raining the whole day. Very troublesome when you want to go out, right? Oh, so nice of you, Pia. Thank you for liking the live here. Okay, so over here, you are using more electricity. So C is wrong. And for D, falling asleep with the TV switched on, you're wasting electricity as well. Okay, these are all, C and D are all wastage of electricity. So your answer is supposed to be number 1. Very straightforward. Yes, thank you, Hasmi. Okay, very good. Everyone, and okay so far? No questions? Okay, now let's move on to the next one, which is the ones that a lot of students tend to get this one wrong. Your water cycle topic. Water and its changes in state. So you all can, if you all know that you all got the worksheet and you've seen the questions ready, you can send in your answer. Okay, see, look at the chat. There's a lot of mixed answers here. You see, you notice that, suddenly so many different answers. Okay, now, let me tell you what is the correct answer. The correct answer is actually 4. You all must be very shocked. No one, I think a few of you only, I think none, so far I see the chat, right? None of you actually chose 4. Let me explain why is it 4, okay? See, this is one of the tougher questions. Okay, usually water and it changes. Later I explain, okay? Please, I'll explain, don't worry. Okay, so why? Why is the answer 4? This one, a common mistake made by a lot of students. Okay, so there are 2 cups of water placed in a room, right? Which was at room temperature. Okay, I gotta highlight the important things when it comes to water and it changes its state. Okay, so room temperature. Okay, the room temperature was 30 degrees Celsius. The surrounding temperature is 30 degrees Celsius, right? So then the reading on the scale show the masses of the cups when they were placed on the digital weighing scale at the start of the experiment. Okay, so you all can see there's a fair test, right? They both use the same amount of water. Take note, okay? They use the same amount of water at the start of the experiment. That's why the mass is the same. Okay, you can see here. Mass is the same, right? Okay, but what is the difference here? Okay, everybody listen. Okay, the correct answer is 4. Okay, but the difference here is always find out the change variable. Does anyone know what's my change variable in this diagram? Sometimes they don't write it down in words, but they show you in a diagram. Very good YS is the temperature of water. So if you look carefully, both of them, the water, are at different temperature. Okay, so now different temperature means different processes will occur. Okay, let's focus on cup A first, okay, everybody? If you focus on cup A carefully, this is hot water, 85 degrees Celsius. Oh, okay, you can get the worksheet on our the bio. So you must go to here over here at A Grader LC. There's a link. Click on the link, and you will be directed to a web page, and then you can download the worksheet from there. Hi. Oh, you're in A Grader Science. Oh, which outlet? Okay, so for this, right, what happens is that hot water. Does anyone know what will happen if my water is hot? Does anyone know? Oh, Boon Lay, the one at Jurong Point, right? Okay, evaporation, right? And what? Okay, good. So very good. Thank you, Crystal. Thank you, YS. Me? I'm at North Point, and I do online classes. Yeah. Okay, so over here, right? Very good. Evaporation. So when water evaporates into water vapor, but this question is special. You know why? Because there is a lid. So if there is a lid, did any water vapor escape? Oh, sometimes I go. Hello. Sometimes I go Sembawang. I send my daughter there for creative writing tuition. Oh, now you get it so fast. There's a lid, right? Means what? Water vapor cannot escape, right? So when water vapor cannot escape, it will stay within the cup. Okay, and not only that, when they stay within the cup, right? Then they will touch the surface of the cup. You see the drawing here? Okay, they touch the surface, and then some condensation can take place on the lid or on the cup. Okay, so is there any loss in mass for cup A? You all get it? For cup A, is there anything escaping? Is there any loss in mass? Yes, very good. No, right? Okay, so now you understand already. So cup A, because of the lid, some questions don't have the lid. This one have the lid to trick you all. So this one, because of the lid, right? The one that is correct, cup A, okay, take note. There is, I write down, okay, the notes. No loss in water vapor, okay, or water in a way, because the water end up water vapor condenses again. So when there's no loss, okay, there's there's nothing, the amount of substance still stays the same. That's something to do with mass, right? Mass is the amount of substance or matter in an object. All right, so the mass will not change. Yeah, Sun Plaza. Oh, I don't do science at Sun Plaza. I do science at North Point. But I don't. But I'm not have taking any P6s class at North Point next year. P6 next year don't have. But I got on P6 online class only. Okay, so now for cup B. Oh, you have so many Sun Plaza also. Okay, so let me explain about cup B. Does anyone know if it's cold water, 5 degrees, right? Look at the temperature. 5 degrees means it's cold, right? Cold means okay, cold will they evaporate if it's colder? Will they evaporate if it's cold? No, right? So what happens is that, but what is there all around? What is there? What is there all around the cup? Yes, very good. Only condensation. Yes, why? Water around the cup. Water vapor. Very good. Okay, water vapor, right? So let me write down. There's water vapor all around. Okay. So what will happen when water vapor comes into contact with the cooler surface? Yes, very good, Vivi. A lot of you are answering correctly. Very good. So it will lose heat. It will condense into water droplets. Okay, so these water droplets, is it something extra? It's something extra, right? Because the water vapor is actually from the from the surroundings. It's not recorded down in the mass at the start, right? Yeah, so it's something additional. So when this water vapor comes into contact with the cooler surface, it loses it, it condenses, and then water droplets will start forming on this cup. There is additional water. So when there's additional water, there's more mass. Okay, so additional water on the outer surface of the cup. So there's more mass. Very good, Eddie. So when there's additional things, extra things, mass will increase. Okay, so it will be more than 55 grams. That's why my answer is supposed to be number 4. My answer is number 4, right? Actually, is because of the lid. If there is no lid, let me just explain, okay? If there is no lid, water vapor can escape, then the mass of cup A will decrease. That is if there is no lid. Okay? Can? Understand already, the rest of you? Did someone say they don't understand cup B? I saw just now. Understand already? Sister? You get it already? Okay, so a lot of you did, yeah, you all must be very careful, okay? It's because of the lid. Oh, yes? Yes? Yes, Kuma. Do I call you Kuma or? Okay. All right, gonna move on. No problem. No problem, Pia. Okay, let's move on, okay? This one is one of the tricky questions, so you must be careful. Watch out for such questions in PSLE next year. Okay, now this one. Okay, now for this question, right? Oh, Krishna. Okay. Easy, yeah. Hey, it's good that if you find it easy. Okay, so let's take a section B. All right, so write your answers in the spaces provided, and the graph shows the temperature of a farm across several hours. So now the focus here is actually the temperature. Okay, I screw up a bit, okay, so you can see the full question. All right, and it says that Jean observed that some white solids could be seen on the surface of the leaves at about 6 a.m. Okay, so the question is, they're asking us to explain how the white solid form. Okay, yeah, very good question, Jessica. So what do you think are the white solids? How come got some white circles, sometimes circles and everything? Oh yeah, no color today. Thank you, Kiwi, for replying for me. Yes, it's no solid. Dewdrops is liquid. Yes, I saw someone ice. It's actually turbo. It's so cute. You said more. No, no. Okay, so this topic, the moment you see temperature, okay, and they purposely give you a timing, right? Then nothing to do with wrong. Okay, okay. So for over here, yes, it's actually tiny ice on the surface of the leaf. All right. So over here, okay, let me write this one down. Okay, these white solids are actually tiny ice on the surface of the leaf. Okay, why? Why is there ice? Look carefully. Look at 6 a.m. What is the temperature of the surroundings at 6 a.m.? Can anyone tell me based on the graph? Yes, it's cold. Yes, it's cold. Below 0 degrees Celsius, right? It's around -1. Okay. So at about 6 a.m., the temperature is actually about -1 degree Celsius. Okay, good. YS. Yes. Okay, so when it's -1, right? It means that when it comes to water, it is actually below freezing point already. Okay, you remember water freeze at what temperature? Does anyone know? Anyone? Good, Crystal. So remember, okay, water freezes at 0 degrees Celsius and colder. Okay, very good. So based on this, what happens? Okay, but you already know the idea. Water freezes. But why got water? Because there's what? All around. There's what first? Yes, good. You must remember, okay? Initially it's warmer, right? Initially before 6 a.m., it might be a little bit warmer. Before 4 a.m., it's a bit warmer. So there's actually water vapor. There's still water vapor all around the leaf. So when there's water vapor all around the leaves, what happens? It Okay, and for science, we try to say warmer water vapor in the surroundings. Straight cannot gas, don't straight away freeze. Freeze is from liquid to solid. So water vapor is a gas. You cannot say it freezes first. So cannot say it freezes first. Like that, you all will lose marks in exam. Yes, it must come into contact. It must do not straight away jump to condensation also. Okay, so water vapor from the surroundings come into contact with the cooler surface. So take note that the leaf is actually the cooler surface. Okay. Let me erase first. Okay. Yes, condensation on the cooler surface. All right. So what happens here is there is a cooler surface, which is the leaf. All right. It comes into contact with the cooler surface, lose heat, and condense into water droplets. Good. Okay. But water droplets is still liquid. How come it becomes solid? You must explain further. Does anyone know? After that, so do you know, Kahoot? After you mentioned about the water droplets, it become water droplets, right? What happens to the water droplets? Okay, the water droplets. But you all must use the graph. Okay, a lot of students, if you all never use the graph, they give you the graph for a reason. If you explain without using the graph, you will lose marks. So you must say that at 6 a.m., okay, the temperature is below freezing point. All right, so the water droplets will lose heat. Very good, someone said lose heat, and freeze into solid, into ice, which is the white solid. Okay, so let me write down the whole thing. Okay, very good. So for this question, you must mention what you can see in the graph. Okay, so for this explanation question for water cycle, always remember, okay, I'm going to write down the point form. Okay, you must always tell me whether it lose heat or gain heat. This is my describe. Okay, you must always tell me what process is occurring, science concept, and what is being formed. This is the standard for all questions. Okay, but for this question, you must write something extra because they give you a graph. You must talk about the graph also. Okay, all right. So for this, let me write this one down. Okay, so starting, we say that water vapor in the surroundings comes into contact with the cold surface of the leaf. Yes, cooler or colder surface also can. Okay, comma, lose heat and loses heat and condenses into water droplets. Okay, but we cannot end here. Okay, this red section will give you 1 mark. Okay, only 1 mark. All right, and then let me write the other mark in blue. Okay, so, and then after that, you must talk about the graph. So at 6 a.m., the temperature is below freezing point of water. So the water droplets loses heat and freezes into ice, forming the white solid. You're talking about Labubu now. You're likes Labubu so much. Hey, why is he sorry? Yeah, okay. Okay, I'm gonna highlight the keywords, okay? You don't have Labubu? There's a trend, it's a trend now. No, it's okay. You're fine. Okay, I'm gonna highlight the key thing, okay? So water vapor, contact, colder surface, loose heat, condensers, water droplets. These highlighted points must write down to get your 1 mark first. And after that, you must say that the temperature is below freezing point. Water droplets loses heat, freezes into ice. This will give you another mark. Yeah, it looks the rabbit looks a little bit scary. Yeah, it looks like a rabbit. Scary one again? Understand so far? Do you have any questions for A? No questions for A? Any questions for A? Okay, then I'm gonna move on, alright? So let's look at B. Do you all know the answer for B? If you all know, you can yeah, you can send it in, okay? So over here, when Jane returned to observe the leaves at 10 a.m., the white solids could no longer be seen. This one is simpler. B is simpler. Explain why. Do you know what happened? Okay, tiny ice gain heat and melted. Okay, very good. But you all must talk about the temperature first, okay? So they purposely tell you all the time, right? So they purposely tell you the time means must use the graph. Okay, so you must say that at 10 a.m., you can say that the temperature is higher than melting point. So the ice gain heat. Yes, the white solids gain heat, melted, and melted to form water. Very good. Oh, cannot write all point form. The teacher, if you write all point form, the teacher want to look at your phrasing of the answers also to your phrasing matters because if you phrase it slightly differently, in English you'll learn, right? If your phrase a sentence slightly differently, it might mean different things. So cannot write point form. Okay, so over here, all right, you have to describe. Very good. Describe the temperature first. Remember, okay, those of you in A grade, you should know explanation question got at least 2 steps. At least DS. This is not an experiment, so you just use 2 steps without results. D for describe what you can see in the graph. Okay, and S is science concept. Okay, so your science concept is about the heat and the processes that's happening. Okay, yes, very good. Okay, so over here, describe what you can see first. Okay, at 10 a.m., the temperature is above melting point. Okay, has or so the white solid, you can say you could also say ice is fine, gain heat from the surroundings, sorry, I put gains, okay, gains heat from the surroundings and melt into water. You're all in science A grader. Wow, you're spamming the likes. So nice of you. So sweet of you. No Kahoot today. This time I must put a sign, a big sign. No Kahoot today. Is for that other we only had doing Kahoot once a week now. So it will rotate among the different levels and subjects. Okay, so I'm going to highlight the key things. So you must say that the temp is above melting point. The solid gain heat melts into water. You're going where next year? Everyone okay? Understand so far? A lot of you send in the correct answer. Your explanation is good. But you all send into the chat, you all can put in point form. No problem. But during exam, don't write point form, okay? Okay, I'm gonna move on. You all no questions? Okay, so let's look at C. All right, so from the graph, what is the time? Oh, this one very easy. I show you the graph again, okay? But I because not everyone have the worksheet. I show you the graph again. But let's look at the question first. What is the temperature of the farm at 12 p.m.? So everybody, those of you who don't have the worksheet, remember 12 p.m. I'm showing you the graph. What do you think? Wait. 12 p.m. You must see carefully, you know. 6 or 8? 12 p.m. 12 p.m. This one. 12 p.m. I give you a clue. I draw the line for you. Oh, okay, later I show 5B again. Give me a moment. Look at the line carefully. Yes, it's 6 degrees Celsius. It's over here. Okay, this is 6. The one above is 8. You don't see wrongly, okay? I know it's a little bit tiny to be seen. I zoom in for you, like this. Okay. All right, so it's 6 degrees Celsius. Okay, so the answer is over here. Let me write this one down. All of you get it correct. Just have to read the graph properly. Okay, for those of you who just now someone asked for 5B, this is 5B. What? Oh, why you call yourself hot fella? Yes, as you increase in altitude LJ in a JL, you as you increase in altitude, right? The colder the temperature becomes. Okay. Transpiration. Transpiration is not tested in PSLE, so not necessary. But it cannot be okay. But anyway, right? Even if transpiration, you talk about transpiration, right? It's not accepted because it is quite cold. Okay, so it's very cold. So we don't. They usually plants will not want to lose any. Will not open its stomata. So it is too cold. The stomata will be very small. So we try not to. It doesn't want to lose so much water. Okay. Okay. Okay, Ken? I'm gonna move on. Okay, everybody, let's look at question 6. Oh, hi, Bia. A science A grader. Where? Okay. Is it the Sembawang one? Okay, so let's look at question 6. If you know the answer, you all can tell me, okay? So Susie. No problem. But transpiration not tested in PSLE also. Okay? Oh, Sengkang CC. Okay, so over here. Okay, so Susie, pot, and I always like to highlight important keywords, okay? So you all try to underline and highlight equal volume of water into 2 glasses C and D. Place them on a table at room temperature. Okay, so now is room temperature, okay? So now always find out what is my change variable in this experiment. Does anyone know what's the change variable? Neighbor dog barking. I have a dog too. What's the change variable? Does anyone know? Change variable? What higher? Oh, you're answering A, is it? A, the answer is higher. Very good. But does anyone know what's my change variable? No, not material of the glass actually. Is whether is what? Any idea whether the glass is a single layer Or yes, or it has a double layer. Very good. So the change variable here is actually the number of layers. Change variable is the number of layers. Okay, to be more specific, what does layers have anything to do with this topic? Okay, it is something to do with the air. Let me arrow down, okay? Yes, change variable is something that is different in the experiment. Okay, so which is the thing that will be tested? That's correct. Okay, so if you compare, look at the diagram carefully, you can see the change variable, number of layers. And because of these layers, there is air trapped there in between the layers. So to be more specific, it's actually air that's affecting the results of the experiment. Yes, YS. Yes, YS gave you a clue already. So, okay, air is actually a poor conductor of heat. All right, so after 10 minutes, she measured the temperature of the water in each glass. And question A is asking us, okay, will the temperature of glass D be higher, lower, or the same than C? And explain why. Everybody, the starting temperature is the same. Okay, if you look carefully, water is at 80 degrees at the start of the experiment. Does anyone know? Someone answered the first part already. Someone said that, but does anyone know? Can anyone know is same, higher, or lower for the temperature in glass D? Okay, some of you say same. Some of you said higher. I've seen just now. A number of you said higher. Then what? Some say same. Okay, okay. The correct answer is actually higher temperature. Okay, so why? Ayo, why you call yourself 小魔鬼? Okay, but thank you, thank you for congratulating. Okay, yes. All right, so over here, the correct answer is usually higher. But why higher? Okay, let me explain, okay, everybody. So, temperature of D will remain high, while temperature of C will go down quickly. Temperature of C actually will decrease faster. Okay, why? Why it will decrease faster? Okay, you must understand that C, does it have any air in between the layers? Is there even two layers? Does anyone know? Okay, so for C, right, you can see that there's only one layer. There is no air trapped in between. So what happened is, this is the hotter region, right? Water is the hotter region. And how does heat flow? Does anyone remembers? How does heat travels? Heat always travels or flows from a... Does anyone remember? YS, VV, very good. But we try not to say trap more heat. In this case, we don't say trap more heat. We talk about whether gain heat or lose heat, fast or slow. Yes, hotter to colder, warmer to cooler region, right? So for this, over here, okay, what happened is heat will travel to the surrounding air faster. Okay, so take note, okay, glass C, okay, because there is no, let me write this one down, okay, you must understand that glass C, there is no air in between. So when there's no air in between, it will lose heat. Always remember, hotter things lose heat, okay? Lose heat faster. So lose heat faster means it becomes colder faster, okay? So the temperature, lose heat means temperature will decrease, right? So temperature decreases faster. So temperature will not be high. Temperature decreases faster. You understand already? Okay, while for D, because of this air, someone mentioned is a poor conductor. So it's a poor conductor of heat. What will happen is that it will lose heat fast or slow, everybody. You must focus on the lesson, okay? But thank you for liking. I know. Lose heat fast or slow if air is a poor conductor. Anyone? Someone's slower. Very good. So air is a poor conductor. So even if the water is hot, it will lose heat slower, which means that temperature will decrease very slow. So that means the temperature from 80 to 79 to 78, but for glass C, it already maybe decreased until 70 and 60 already. Correct? So cup B or glass B, the temperature will be higher. All right. So, but for explanation, right? Let me answer the first part first. You must say temperature of water in D is higher. Okay. But why higher? Very good. Thank you for all your answers, VV Beer. Why higher? Remember, this explanation question, okay, they did not, although this is an experiment, did they give us the result? Did they tell us the temperature of the glasses? Did they tell us the temperature of the glasses? So in this case, they never tell us the result of the experiment. So if they never tell us the result of the experiment, those is a two-step answering technique. Yes, JL, eventually, if you leave it there for a long period of time, eventually both of them will reach room temperature. Yeah, correct. Okay, so we need to describe without results, two steps answering technique only. Okay, you need to describe about air. Describe about the change variable. You know that there are two layers, single and double layer, right? Okay, so then, but single double layer doesn't explain about why it will lose heat fast or slow. So you need to mention about the air. Okay, the air is the important part here. Okay, and your science concept talk about heat loss fast or slow. Okay, so how are you gonna say? You must say that it's okay. Sorry. Okay, so for this you must say that as air is a poor conductor of heat, okay, comma. Okay, wait, let me just add in and D has a layer of air, comma, okay, the water in D will lose heat slower. We use comparison words here, okay? You have to compare. Why do you choose, why you say D is higher than C? Okay? So, to lose heat slower to the surroundings. You're asking about when you're going tuition. Okay, I'm gonna highlight the key thing, okay, everybody? So you must mention temperature of water is higher, air is a poorer conductor of heat, so water will lose heat slower to the surroundings. That's why the temperature remains high. You all have any questions? Any questions so far? No? Very good, YS. You understand? Okay. No questions, I'm gonna move on. B and C is simpler. Oh, only left this B and C. Because yeah, you don't have question, good. Okay. So now let's look at B. Part B, Susie emptied glasses C and D and poured an equal volume of water at room temperature in both glasses. She placed both of them into the freezer now. And which glass will the water freeze first? Okay, so you're not done copying? Let me go down a bit. Okay, Pia? Okay, freeze first. Okay, very good. Some of you sending your answer already, but can you freeze? In order for the water to freeze, means that the water must gain heat or lose heat. Everybody? Empty the water into where? What do you mean? Oh, You just pour away somewhere lah. They maybe in the toilet bowl, maybe in the sink. The one not important. Yes, very good. Very good, Eddie. Very good. YS. Yes, it's supposed to lose heat, right? So if I want it to freeze first, means it must lose heat fast or slow. Any idea? Fast or slow? You must think, always have this kind of thought processes when you're doing the science question. Lose heat fast or slow? What do you think? If I want water to freeze first, that means it must lose heat. A lot of you mentioned lose heat. Very good. Fast. Lose heat. You want it to freeze first. You want the temperature to go down faster, right? I want the temperature to reach freezing point faster. So must lose heat faster also. So if I want it to lose heat faster, do I want a poor conductor of heat in my setup? Any idea? If I want it, no, right? Very good, YS. So which one don't have the air? Air is the one that is causing the problem. Air is the one that is making things slow. So which one? Yes, very good. C don't have air, right? So you remember glass C have no air? So glass C have no air. Everything will be fast. You will gain heat fast. You also will lose heat fast. Okay? So the answer is glass C. Very good. Yeah. Okay. Any questions? Understand so far? Very good. Okay. Last one. Very good, JL. But we must use comparison words. Okay. So like faster, slower, etc. Good. Okay. Last one. In the space below, using arrows, draw the direction of heat flows. Okay, this one a bit difficult. Maybe you just tell me, okay, whether the arrow should point into the glass or point out from the glass. Wow, so sweet of you. Thank you for liking the video, the live. The arrow should be pointing inwards towards the glass or outwards, away from the glass. Hey, very good. Towards the glass. Everybody, heat flow, heat flow. Freezer. Okay. Okay, the correct answer is outwards. Very good. Thank you for all the arrows. It's actually outwards, not inwards. Okay. Why? Always remember, heat always flow from a hotter to a colder region. So, which one is my hotter region, everybody? The surrounding is hotter or the water inside the glass is hotter? Surrounding is hotter or water? Water is the hotter region, right? Because it's room temperature. Take note. See? Okay, let me go down a bit. Room temperature water, okay? So, room temperature, this is the warmer region. The freezer is very cold. So, always remember heat always moves from a hotter or warmer to a colder region. So, arrows must be pointing out. Yes, very good. Thank you for all your answers. You're so you're so sweet. Y'all keep liking. But must concentrate, okay? Very good. Thank you for all your answers. Surrounding is not the warmer one. It's a freezer. Everybody, you must read carefully, okay? It's the freezer. Freezer is very cold. Okay? Okay, very good. So, a gentle reminder, okay, just want to tell you all that just now you keep asking whether I'm teaching, right? I'm teaching webinar classes, which is online class on Thursday, P6 Science. Next year, if you are in P6, I'll be teaching you. Okay, if you join the online classes, okay, there's a free trial. Yeah. Okay, you can register in the link in bio if you want to try. Okay, so and let me tell you about good, you got pay attention, very good. So let me tell you about the next live. Look at top. Okay, so there'll be creative writing piece next year. Okay, next year, if you're in P6, you can join the live. Creative writing tomorrow at 7 p.m. So sweet of you all. Thank you for all the likes. No Kahoot today. Hey, I say no Kahoot today already. Oh, you mean the tomorrow one? I am not sure actually. Yeah. Yeah, I think tomorrow one is, yeah, I think don't have, but you just join and learn. Okay? Okay, so sweet of you, Eddie. Okay, so if you have no more questions, okay, thank you for coming to my live. All right, if you want to join the webinar or the online class, you can try it out. Okay, there's one free trial lesson. Okay, then I see your. Okay, wait, I wouldn't see your because I'm going on a holiday. So someone else will do the P6 science 2 weeks later. Okay, I see yours should be in mid-December. Okay, bye. See you. You also safe travels. Okay, thank you. You're so sweet. Thank you. Bye bye. Oh, I'm going Japan. Ayo, so sweet of you, Pia. Bye bye. Enjoy your holidays. Okay, for those of you who are going overseas as well. Oh, you're also going Japan? I'm going Osaka. Which part of Japan are you going? Yes, you too safe travels if you're going overseas. Yeah, you also enjoy, okay? Thank you. So sweet of you. Bye bye. Oh, you're going Taiwan? Enjoy yourself. I'm going Osaka, not Tokyo. Yeah. Bye. Oh, you're going China? Enjoy yourself also. Okay, the food is China food is nice. Oh, you're going Hokkaido. Oh, it's freezing now, Hokkaido. I never tried like 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 0 degrees. I never tried going to a country that's 0 degrees Celsius and below before. Maybe I should try one day. Oh, enjoy yourself in Malaysia. Genting, is it? China is coming to your house. What are you talking about? Okay. You're going to Tokyo, enjoy yourself. You're going 8 grade to study, not taking a break? No. Okay, okay. If you want no more questions, I'm gonna end the live, okay? Enjoy yourselves, okay? If you're going holidays. Okay, I'll talk to y'all during the live in mid-December. Okay, all right. That's when I'm back. Okay. Oh my goodness, vomit many times. Hope that she. Oh, is it because that she get car sick? Okay, like yeah, some people if they're too long in the car or the boat, right, then they have motion sickness, and then yeah, yeah, they will puke because of some liquid inside the in your brain and in your ear. Okay, okay, see you. Bye. Let me end this live. Okay, bye. Bye. Thank you for coming.